So the work with the transactions is not an enhancement we are seeing with actually an enhancement to the SQL use of the queries to be utilized to interrogate the database engine, but also we are going to see an enhancement in behavior. In the sense of what we're going to see in this unit number 4 is the group of properties, preferences, and features to enhance the security view of a transaction, not a query. We're not going to talk about a query as per a query definition, but we are going to talk about a transaction for a data process and to transmit the request and to retrieve a response from a client to a data server, which is a database, mainly database management system, and vice versa, from the database management system to the interface. So for both directions, we are going to talk about a transaction fully, and this transaction might carry one query or multi queries. So in all cases, we are going to talk about a process to happen. Thus, we are going to talk about the working with transactions. We are not going to pass actually talk about the security related to the password of one query. Let's say, for example, here select or insert or update or whatever. No, we are going to talk about the transaction. I insist on the word transaction here because the features, the preferences, and the options we are going to see that they are covering the transactions as a security measure. They are tackling a transaction and they are compatible with a transaction, not a query. We will see the differences across this chapter. So we're going to see a very, let's say, a stressful, let's say, group of properties, which are the ACID here. We're going to define them one by them. Let's tackle them in details in just in a while. First of all, this is the index of this chapter. This is what we're going to see. Mainly, we're going to discuss the transaction itself as per definition related to the properties that they have actually to be carried out with every each single transaction, and we are going to see some of the related ways how to pass a transaction, how to use it. The ACID as a first and main group of properties dedicated to transaction, they are standing for atomicity, consistency, isolation, and durability. They are actually context of logical process to a transaction to guarantee a secure and scalable and trustworthy transaction. Means we are going to do create a transaction and manipulate it in a logical way. We are not going to build and utilize a hardware to finalize this group of properties, but we are going to manipulate it in a logical way in the context of development in order to guarantee the security. Those are logical properties to implement on top of a group of whatever one or group of transactions. So let's see this graph here. Actually, everything is remote. We are having clients at the end. Still, the graph actually this same. We saw it in unit number 3 and unit number 2. Also, still is the same, and still the properties we are going to see they are still applicable on the same diagram here to make us understand that the security they are usually built on remote service delivery. Great. Let's take an example. Let's take an example to make you understand what does it mean a transaction, not a query. What does a transaction represent in a system in general? You as a user, me as a user, everybody, everyone, anyone. Actually, for the purpose of renting a car, to rent a car, the process has to happen like so. You have to know what car you have to choose. You have to make the payment for the car used, and then after you have to take the car and go out. You have to leave. You have to go away. That was a full process happening. Digitalizing this process, what is the purpose? Renting a car. There is one task to do. Just rent a car. To rent a car, we have to do all those tasks. The user has to do all those tasks. He has to choose the car. After choosing and confirming this, the car he needs, he has to pay for that chosen car, and then he has to take it and leave that area. He has to annotate that. He has to confirm that he left in order to confirm that he rented already. This is a one transaction. This is a one process. Digitalizing it becomes one transaction. So we are not going to rent a car. It does not stop at the level of just choosing the car. No, it is not finished. If he choose the car and pay and leave, he did not finish. He did not take the car. He did not take the car. So still did not finish. In a sequential order, first, second, third step. In the sequential order, there have to be an order here. He drives the car out. That's it. No, he chosen. He paid and he drove it out. Now the process finished. Then after we can talk about the digitalization to be a one transaction. One. It is a one single transaction here in this case. So since it is a one transaction, we will be able to develop it. If it is missing anything, we cannot talk about transaction. We cannot. We can talk about something else, a query or a process or a test or whatever. But it is not a transaction. A transaction has to be meaningful and has to be delivering a process, a service at the end of the day. So if you complete your process, so the transaction has happened. Let's have one step further. We took the example of the car rent, the rental of the car. Okay, let's have a more sensitive and more coherent example, and this is from real life also. The ATM withdrawals, the automatic transfer, let's say, or transaction machines, the distributors, the machines actually all of us, we used to withdraw money or to even deposit money. The ATM actually, it's an automated computerized device, hardware device, utilized, delivered and provided by banks, bank companies, and utilized by end users to withdraw money. Easy. What's the problem? There is no problem. Here we are discussing the technology. Okay. How the process is happening and what service does this ATM do, technically speaking? Actually, every user has to check, this machine has to check his account. Every user wants to use this ATM machine. That user, his account has to be checked. Okay, I'm going to use the ATM bank available near to me, and I'm going to use to withdraw 1,000 riyal. Okay, great. Good money. That's great. Let's do that. If my account have, or if there is enough money or not, the ATM machine will give me. Otherwise, no. See what I said now. The ATM has to check if I have money or not. I'm going to ask for 1,000 riyal. Do I have 1,000 riyal in my account? That is a checkup that the ATM has to do. That is a checkup that the ATM machine, the system controlling this ATM has to do. Okay, that's great. Okay, account balance is available and we have enough money or more than that. That's great. So we can do the withdrawal. The machine will give me money. The machine will give me, hey, Murad, take the money, retrieve the money. It will take it out. It will bring it out from the machine and I will hand it. I will take it in my hand. Great. What happens after? Khalas, I go. Yes, you go, but the ATM machine will still has to deduct the money given it to you from your account. The account checked at the beginning has to be updated. Must. It will not give you money without deducting the number or the money, the amount of money you took from your account balance. It has to be deducted. The number you took 1,000, it has to deduct 1,000. You took 1, it has to deduct 1, and so on. There have to be. It is a consequence. There is no doubt that it has to happen. There is no understanding here. It has to. It is a must to be updated. Small recap, because before I pass here, small recap. So the transaction we are talking here, it is that we are willing to withdraw money. What happens? The machine has to check up. What happens to finish this transaction? The machine first, in sequential order, the machine has to check up the account balance. Checks up only in case of availability of balance, means there is enough balance in your account or in the customer's account, means whatever the amount requested at the first checkup, it has to be either available or more than that in order to withdraw, to give him the money. Yes, take, here is. Then after number 4, after withdrawn, after given, there have to be actually an update to the original checked account. 1 checks who are you and what do you want. 2, if validated and what you requested is available, we withdraw. The machine withdraws to you, to the customer. After withdrawn, number 3, the machine still has to update what? The checked account. It has to update the checked account by deducting the amount balance, the amount money from the available balance. 4 steps. Clear, actually. There are other steps to do also, but clearly for us as a human beings, those 4 steps, they have to happen all together. They have to happen all together. What does it mean? Means the system here, the ATM system, does not have the right to withdraw money without update. Or the system also does not have the right to update the balance without giving the money, without withdrawing the money. It's not allowed. The ATM machine does not have to withdraw, check up the validated, actually, the account, how much is there, without checking up the identity here. So all of them, they are related with each other here, those 4 steps. They are related 100%. Those are related, correlated, and they have to accomplish one unique purpose, which is the transaction of money. Means here, at this point only, if the user actually manifests himself to the machine and the machine checks him and checks his request, okay, what he requested is available, that's great. It gives him the money, and here the machine decides to stop. It will not update. No, never. Never. Or it's not the machine that stops here, but for example, there is an electrical shortcut. There is a problem, a storm or a toner or something like that caused the electrical shortcut. The machine did not update. What happens? The amount has been withdrawn from the bank and will not be updated. No. After the electrical let's say power comes back, there have to be a scenario to update. There have to be a scenario, the backup or something like that, restore activity, to update the original account. So there have to be. It's a must. It's not a request of yes we can or not. No, it has to happen. So they have either all of them to be executed or all of them to fail. Either all to execute, the 4 here in this example, or all to fail. Execute all or fail all. This is an atomic view. This is an atomic view. This is an atomic view. There are 4 different queries to do, but they are seen atomic. They are seen 1. Means atomicity here is viewing a list of queries. I use the word queries. List, group of queries to be seen as one process, which is true here in this example. We have to do them all together, one process, or no, all of them, no. This is an atomicity case. This is an atomic view of a list of tasks to do. Those are a group of standalone functions or activities or operations or queries to be executed all together or to fail all together. There is no doubt. Either to execute them all, the four in this example, or to fail them all. This is an atomic view. Any questions at this level, please? I took enough time to explain you what does mean atomicity. Okay, since you know ask me, actually it's clear here. That's great. Let's have an example of the atomicity here. Let's take an example of an atomic transaction here. We're talking about the TSQL. Sorry, we are talking about the TSQL. Since we are talking about the atomicity, which is related to transactions, not related to the queries one by one. Select a star from students table. It is already one atomic query. Selecting a star from students is one atomic query already. So it does not need to have any constraint or doubt or what problematic view to say that it is atomic. No, it is one query to do, either to do it or not. So we are talking about atomicity of transactions, not queries. In this example here, we are having the purpose to execute two statements, which are insert and insert. In this example, we are going to execute a stored procedure, user-defined procedure, user-stored procedure here. And this user-defined procedure has to do two inserts. Insert first values and insert second group of values. Okay. What you are going to do is that we are going to create a stored procedure. And the body of this stored procedure, here it is. The body of this stored procedure here, this block here, body of this stored procedure here has to be declared as atomic, means the system or the let's say the database management system, since it is stored procedure, has to see this block here from this beginning until the end as one statement to do. He has to execute all in just one shot, either yes, both, or not. It is seen as atomic. It is seen as atomic here. Great. We'll talk about the isolation just in a while. Not now. We'll define it later. But for now, what just I want to bring your attention to is that we are generating a group of queries in a one transaction. How? By specifying that, by creating a procedure, and this procedure has to specify that the body of this procedure is atomic. That's it. No more, no less. Procedure, we know what is a procedure, and the beginning and the end, we know the syntactical view of what is a procedure. We know this is not new to us, and we are just adding the word atomic. We're just specifying that this procedure has to be executed in an atomic way by specifying the keyword atomic. Full stop. No more, no less. How many statements we have? In this example, we have two. But can we have more than two? Absolutely, yes. We can have 3, 4, 5, n. N many means queries, many statements. Absolutely, we can. As many as we have. The full block from the beginning until the end will be seen as atomic. Full stop here. Very easy. What is this T1? What is this T1? Actually, this is actually a table we created here. It's this is a full process. We are going to create a table, and this table will be utilized to be we will populate it. We will fill it with data. We will fill it with data. value 1 and v1 and v2, they are variables, since the arrobas variables here, they are declared here. They are declared here. What are the values here in this example? When we call, when we execute, we are replacing those values here. What those numbers here, 1 and 2, any numbers, uh, because we are saying they are big int, they are numbers. Any questions in this block, please? Any questions in this block? I took enough time, and I believe that you saw all the details.
No, Mister.
So yes, great. Let's pass to the next property. Now we discussed one of the properties that the transactions has to have. The SQL queries, actually, the SQL, let's say, process, or the process, the TSQL process has to have, which is the atomicity. The second property, which is the C, the consistency. The same. We talk about the same example. We take the same example here, which is the ATM machine withdraw. We are going to actually the same scenario, actually, whether we are going to execute the full transaction or not here, but in the sense of the transaction we executed. For example, the user has asked for 1,000 real, and for a reason or another, he asked for 100 real, and then after he asked for 200 reals within the same process. He did not log out. He re-asked for another money. The full money they have, actually the full requests, they have to be, the group of requests, they have to be updated from his account. I come back to the text to make you understand more. His account has been validated, and he withdrawn the first 100 real, then after another 100 real, then another 100 real, for a list of withdrawals. All of those withdrawals, they have to be also updated in his account balance. All, the first, the second, the third, and all of them, they have to be updated in his account balance. In this view only, after updating his account, actually, if it happened, we preserved the consistency task. Means the list of the queries they have been executed without alteration. The list of the queries, they have been executed without alteration. So the transaction is consistent. We did not leave in between. We did not stop the work in between. We finished until the end. Thus, the transaction was or is consistent. It would be inconsistent if the work has been stopped in between. It did not finish fully. Here we are not talking about either execute all or fail all. No, we are talking about that the work has to be finished, consistent, terminated, accomplished. That's it, consistent. We have to terminate even after a while. The system has to stop or whatever. We are not talking about they have to be fully executed or fully failed. No, we are talking about terminating. We are talking about terminating the process. The process has to finish. So we do not do only one insert in this example. No, we have to do the first insert and the second insert, both. There have to be a scenario to execute both of them. So we are talking about a consistency. Consistency of what? Of the transaction here. We are talking about the transaction. The consistency of the transaction here. Yeah, the process has been terminated fully. Great. Okay. Now the second property has been, let's say, explained. Means we are going to completely execute the transaction content. Transaction content. Okay. Let's pass to the third property from the ACID properties that they actually have to be still also that has to be applied on each transaction. The isolation, which is in the sense of depriving the transaction content from being interrupted, eliminate the interferences or the inferences or the injections. We do not allow any injection, we do not allow any inference to stop the execution of the transaction queries, the transaction statements. So they have to be executed fully, all of them, they have to be executed. Thus, and this at this level only, we are talking about isolating the transaction queries from the external world. The system has not to allow any. For example, we start transaction number one, which is long enough, has 100 queries. This transaction, the system has not to stop this transaction to start another transaction, then after comes back transaction one, stop transaction one to execute transaction two, and then after comes back to terminate the transaction one. No, no, this is not an isolation. This is an inference, which is breaking the rule of being isolated. Isolated means there is no inferences, there is no interruptions. There is no interruptions at all. It's not accepted. This is the context of isolation. Yes. So, in the context of, if any request tries to stop a transaction, it has to be blocked. No, we have to finish the transaction, or the system has to finish the transaction fully, then after to launch the next requests. Otherwise, no. Any other request sent to the system or to the processor or whatever, when a transaction is running, has to be blocked. Is it clear, please, at this level?
Yes.
Great. So this is the property number 3, which is depriving the transaction from the external world. External world means other transactions or any other requests when the transaction is being executed. Now, everything has to be stopped until the end and the termination of the execution of the transaction in question, or the transaction being executed. The fourth last property that has to be respected, which is the D, the durability. Okay, me, Murad, actually I withdrawn money and the system has run well. You, Fatma, you withdrawn money and the system has run well. Absattar also withdrawn money and the system has run well. But for Khalid, no. The system did not update. He requested 100 riyal. No, the machine giving him only 50. Hey, machine, give me 100 riyal. No, the system gives you only 50. What is this? I mean, this is a change in behavior of the system. This is not a durability. The durability is that the way how it acts for the first user, the system has to continue working for all users the same way. For all users, whenever any user asks the same service, the system has to act in an intact way. The same way. There is no integrity issues here. There is no integrity issues at this level. So we talk about durability. Why durability? Because the integrity is being preserved. The integrity is being preserved. So whatever a process has been happened for the first user, second user, it has to remain for the totality of users completely. No exceptions. No exceptions. If any exception happens, the durability has been broken. The durability property has been broken. If any exception happens at any level, the durability has been broken. Any requests, please here at this level exactly? At this exact level, any requests, any questions? This is great. This is great. So we terminated the 4 properties that they actually have to be a companion every and each single transaction. Here is not an exception. This one, the asset here, the atomicity, consistency, isolation, and durability, they have to be properties seen at every and each single transaction, not no exceptions at all. So every transaction has to be atomic, every transaction has to be consistent, every transaction has to be isolated, and every transaction has to be behaving in a durable way for all users. Durable means for all users. It's not a context to be every day like that. No, but for all sessions. For all sessions, it has to preserve the integrity of the process. Otherwise, if it alters any of the functions, it is not a durability. Clear. So ACID, remember that. So in summary, here is that actually all the transactions, there is no case of exception. All the transactions without any failure, they have to respect the 4 properties, the atomicity to be completely atomic. All the requests or all the queries inside one transaction have to be seen as atomic, either to execute altogether or to fail altogether. Consistent, they have to finish, to get finished fully. The process has to be finished fully, whether in a 1 minute or with a delay or without delay, we don't care about the time, but fully they have to be finished. The full requests or queries in a transaction body have to be executed, all of them. This is a consistency. The isolation, there have to be no inferences permittances, means any request to stop a transaction or to interfere in a transaction process, no, it has to be isolated, it has to be blocked. This is the isolation. Durability for all sessions. We don't say that this is an administrator, so if he asks for 100 riyal, we give him 200 riyal. This is administrator. No, it has to act the same way. Otherwise, the durability has been broken. And this is actually one of the 4 properties that actually being broken. And thus, if any has been, let's say, disrespected, the transaction might run, the transaction might finish running, it will not stop, but there is no security. If any of those 4 properties has been broken, means has been non-respected, has been non-implemented, the transaction might run still. Yes, it can finish, but there is no security. Only one to break. For example, we say that only administrators will not be able to, let's say, log in. The durability is not respected. Thus, the security is not set, and thus the transaction is not secured. It's not, it will not run. No, still it will run, but it is not secured. The work is not guaranteed to finish correctly and properly. If you hear your name, please just say yes. If you hear your name, just say yes.